Hi guys, in this video we will feature 3.4 similar triangle theorems. Now the triangle proportionality theorem you may have already discovered because you jumped into IXL and just went and checked it out, right? A lot of people can actually just sort of understand that proportionality and it makes it a lot easier. So let's take a look at it. This is what it says. It says if a line is parallel to one side of the triangle and intersects the other two sides, it divides those two sides proportionately. And we can see that right there. So let's see. I'm going to get my pen a little bit so you can see it. So again, BD, this section right here, BD from right there, over DA, again, that's our segment right here, BD, over DA. You could also have said AD on this one. Trying to connect the dots right there. That's our segment here, is going to be proportionate to BE, which would be any number or any side length from B to E over E to C, or C to E in this case. Again, now I didn't say anything about these up here, this one and this one. No, that is a caution. These are not going to be proportionate in this particular example. All right. So let's take a look at how it looks. Again, how does this exist? There's parallel lines. Make sure you have those marks, right? But these two that have the parallel marks, you will not set up a proportion. Okay. Make sure you understand that one. So let's take a look down here at the bottom. It says, find the length of DG. So what are we going to do? Set up a proportion. A lot of my kids, when they see the parallel lines just like this, they begin to actually just set up the proportion by setting up a fraction just like this. 32 over 24 is going to be equal to 40 over x. They actually use the triangle to set it up. Let's clean it up just a little bit. There, that's much better. Once again, 32 over 24 is going to be equal to 40 over x. So now what do? Cross multiply. So I'm going to multiply 24 times 40 right here first. Now that's going to equal 960. Then I'll repeat the process because this does create proportional reasoning. We're setting up proportions, right? Some students actually call that the butterfly. Okay, whatever works. Now we're going to multiply 32 times x, and that will equal 32x. We're one more step away. We now have 32x is equal to 960. So what do we do last? Well, we're going to divide both sides by 32. Remember, we are dividing 32 divided by 32. That equals 1. We're not canceling. And then 960 divided by 32 means x is going to be equal to 30. Let's try another one. On our next example, we do see that it's laying on its side, right? But we can still set up this proportion. It's like 10 over x, which is this segment between r and n, would be equal to 8 over 5. Why can I do that? The triangle proportionality theorem. And I also see this right here, right? Good job. So we now have it set up. 10 over x is equal to 8 over 5. What do we do next? Cross multiply. That'll give us 8x is equal to 50. Once again, we're multiplying the x and the 8 and the 10 and the 5. Good job. Now we'll divide both sides by 8. And when we divide both sides by 8, we do get 1x is equal to 6.25. Let's try one more, and then you and your team can get together. What we're going to do is actually the converse of this. We're going to set up this proportion, 42 over 21. We're going to set it equal to 30 over 15, cross multiply to see if we get the same product. If we do, we can prove that MN is parallel to KL. Let's give it a shot. My proportion is set up, and now I'll try my cross product to see if I get the same number. 42 multiplied by 15 is definitely 630. If we see 630 when we multiply 30 times 21, they're parallel. Since we got 630 when we multiplied 30 times 21, we can definitely say yes. MN is parallel to KL. Now, get with your group and practice. If you guys fly through all of this, I want you to jump back into IXL. Good luck.